Reporting live from sunny Arizona, my name is Ryan the intern, and this is my colleague Pedro.
Thanks, Ryan. We're here to talk about a novel discovery made by the scientists at Solar Lovin.
They call it the parachute. Let's see it in action.
Take it away, Jenna.
Have you ever left your cat card in your dorm?
Oh my god, my cat card!
Too lazy to run upstairs? You don't want to be this person.
Well, the engineers of Solar Lovin have the solution for you.
One scientist, Dr. Winkleman, from Solar Oven Inc., is here to tell us about how they designed their experiment using design of experiments.
So what exactly is DOE? DOE stands for Design of Experiments and is used as a tool to test different results by changing many different factors at the same time and determining the relationship the different variables have on one another. So, design of experiments was first introduced in the 1920s.
Whoa, Jeremy, don't confuse our viewers.
A DOE experiment consists of multiple factors having an impact on multiple variables, or levels. The different factors can be labeled as A, B, C, etc., while the different levels can be either labeled as A high and A low, A minus and A plus, or simply just minus and plus.
Let's talk to Dr. Shoemaker, who is directly involved in this experiment.
Our DOE experiment consisted of making parachutes that would deliver an object, such as a cat card holder, to drop at a specific height and measure fall time. The most effective parachute, which was the slowest fall rate, would be determined by two factors: the area of the parachute and the string length. Each factor has a set high and low parameter. The levels of the area of the parachute, which was a square, had a low level of 64 inches squared and a high level of 144 inches squared. The second factor was string length, with a low level of 8 inches and a high level of 12 inches. The constants of the DOE included the height at which the parachute was dropped at, which was the second floor of Arbel dorms, as well as the cat card holder. Materials needed to perform the experiment included plastic bags, string, cat card holder, rulers, scissors, and a stopwatch. Testing the parachutes involved dropping each parachute from the second floor of Arbel dorm 10 times for each combination for a total of 40 drops. All the trials were recorded using a cell phone timer and recorded in a data table.
With me on the phone is Dr. Alvarez, President of Data Analysis for Solar Lovin.
Hello, Ryan. Here at Solar Lovin, it was decided that the variables consisting of the area of the parachute and the length of string were of utmost importance for flight time. As previously mentioned by my colleague, Dr. Shoemaker, we tested the respective high and low levels of each variable. In order to conduct our experiment utilizing DOE, we changed the respective high and low level entries to pluses and minuses, a plus representing a high level variable and a minus representing a low level variable. Additionally, to differentiate between the combinations, we decided to call the minus-minus combination 1, the plus-minus combination A, the minus-plus combination B, and the plus-plus combination AB. After conducting 10 trials for each combination, a total of 40 trials enabled one to average the flight time. Furthermore, our data analysts found the standard deviation of each combination set. In an effort to generate an equation that will enable one to predict flight time based on information gathered by the experiment, the following mathematical model was constructed. The averages of the factors are plugged into this mathematical model. In doing so, an average is taken from each interaction to derive the coefficients necessary for the development of a prediction equation. The following charts depict the main effects and interactions between factors. Here is the main equation that was derived by utilizing DOE mathematical modeling methods. This equation is useful in that it can predict the flight time y as a function of parachute area x sub a and parachute string length x sub b. One can clearly see from this surface plot that as both string area as both parachute area and string length increase, so does flight time.
Hold on. Word just in that there may be some possible flaws with this experiment. We should go talk to Dr. Knox.
There were some sources of error for this experiment. The harsh Tucson weather made it very windy outside while the parachutes were dropped, causing the time to be different than if it were a normal calm day. Good morning, Section 10. Today, we can do better by being on time to class.
You don't want to be this person.
Sorry, I forgot my cat coat.